These are examples of linear equations. These are not linear equations. There are many ways of writing linear equations, but we focus on the slope-intercept form y equals mx plus b, where m is the slope and b is the y-intercept. The slope is the ratio of the rise over run. It is the ratio of the change in y to the change in x. M equals y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. The y-intercept is the y-coordinate of a point where a line intersects the y-axis. It is the value of y when x is equal to 0 in a linear equation. Let us take a look at the equation y equals x plus 3. The slope of the equation is 1 and the y-intercept is 3. These can easily be verified graphically. If we take the point negative 3, 0 to be our x1, y1 and the point 0, 3 to be our x2, y2, the slope would be equal to m equals 3 minus 0 all over 0 minus negative 3. This is equal to m equals 3 over 3 or simply 1. The graph of the equation intersects the y-axis at point 0, 3. Hence, the y-intercept is indeed 3. Sometimes, we also want to find the x-intercept of a line. The x-intercept is the x-coordinate of a point where a line intersects the x-axis. It is the value of x when y is equal to 0 in a linear equation. Suppose we want to find the x-intercept of the equation y equals x plus 3. We substitute 0 to y and solve for x using addition property of equality. We get the x-intercept to be negative 3. Again, this can be easily verified graphically. Notice that the graph of the equation intersects the x-axis at the point negative 3, 0. The x-intercept is really negative 3. Let us consider another example. Suppose we are given the equation 4x plus 2y equals negative 6. Note that this equation is not in slope-intercept form. We need to rewrite the equation in slope-intercept form so that we will be able to determine the slope and y-intercept easily. We apply the addition property of equality, followed by the multiplication property of equality. The slope of the equation is negative 2 and the y-intercept is negative 3. To solve for the x-intercept, we substitute 0 to y. We apply addition property of equality as well as multiplication property of equality. Notice that negative 3 over 2 is equivalent to negative 3 halves and it is also equivalent to negative 1.5. Therefore, the x-intercept is negative 1.5. Let us verify this graphically. If we take the point negative 1, negative 1 to be our x1, y1, and the point 0, negative 3 to be our x2, y2, the slope would be equal to negative 3 minus negative 1 all over 0 minus negative 1. This can be written as m equals negative 3 plus 1 all over 0 plus 1. Simplifying, we get m equals negative 2 all over 1, or simply m equals negative 2. The graph of the equation intersects the y-axis at point 0, negative 3. The y-intercept is indeed negative 3. Moreover, the graph of the equation intersects the x-axis at point negative 1.5, 0. The x-intercept is really negative 1.5. Pause this video and answer the following items. Find the slope, y-intercept, and x-intercept of the following equations. Verify your answers graphically. Compare your answers to the following.